I'm back, and now we want to talk about vertical motion. So now we have been talking about sideways motion, so that this velocity up here represented your velocity if you were going sideways. And then this represented your acceleration if you were going sideways. And then these were the how fast equation if you are going sideways. And then this is how far you travel sideways. And then this is the hybrid equation if you're traveling sideways. So what do we do if we are going up and down? Well, we're still going to have this equation here, only we might want to add a subscript to it. So we could say the velocity, average velocity, in the, let's say, z direction. So z is normally up and down in geometry. So this would be the velocity in the z direction would be the distance in the z direction divided by time. And then we could also have this equation over here, and we could say the acceleration when something is going up and down, we could say this is the average acceleration in the z direction. And then this would be your velocity, final velocity in the z direction, and initial velocity in the z direction. So we can have these same equations that we used when we were going sideways if we're going up and down, but we do have to be very careful to label it so that we know which direction that we're going in. Well, things are a little bit easier when something is going up and down because there's a particular acceleration that you experience. So if I take this thing and I drop it, it accelerates. It goes faster and faster as it falls. And so that means its speed is changing. So that must mean it is accelerating. Well, when something is falling, the acceleration is being caused by gravity. So instead of the letter A, we're going to use the letter G. So this is going to be the acceleration due to gravity. It's the thing that is causing for it to accelerate is gravity, so it's the acceleration due to gravity, and it's a number. So as long as you are close, within 100 miles or so of the Earth's surface, and that's what we're going to do on the exam, we're going to say that G doesn't change. It's a constant. Now, in fact, it does, so that the higher up you go in the air, gravity gets weaker. So this number actually does get smaller the higher up you go. But this is going to be 9.8 to two significant figures. It's an acceleration, so its units have to be meters per second squared. And then what's its sign? So gravity pulls down, so this is a negative 9.8 meters per second squared. So the magnitude of it is 9.8, but the direction of gravity is down. So when we take this and we plug it into these formulas, we have to use a negative 9.8 meters per second squared. So that means that in these two, or actually all three of these equations, instead of the letter A, we'll use the letter G. So that the final velocity of an object is going to be equal to its initial velocity plus the effects of gravity. Then the distance that something falls is going to be equal to what was its initial velocity. Now, we can put subscripts, so let's go ahead and put the z's on there. So this is the final velocity in the up and down direction. This is the initial velocity in the up and down direction. And then this is the gravity in the up and down direction. And then over here, this is the distance that it moves in the up and down direction. And then this is the velocity in the up and down direction. And then we can do this as well. So this would be the final velocity in the up and down direction, initial velocity in the up and down direction. And now this R is in the up and down direction. So I know that that looks really bad, but you have to be very careful when you're labeling things so that you don't get mixed up. Am I traveling right, left, up, down? Okay, so that's the reason why I'm putting all these subscripts on there. But it's exactly the same calculations that you would do if something is horizontal. The only difference is that instead of the letter A, you're going to put in the negative 9.8 meters per second squared. So put that in here, here, and then those would be the equations that you would use. So here are all of the equations then put together. And here's a sample question that go over this to illustrate how would you use these formulas in order to calculate a problem. Okay, let's take a break, and when we come back, we will talk about trajectories.